The title of our project is Detecting the Optic Disc in Digital Fundus Image Using Morphological PCA and Stochastic Watershed Transformation. Diabetic retinopathy and glaucoma are some of the common causes of visual impairment and blindness. So in our project, we are going to locate the optic disc from the digital fundus image such that the diseases can be detected at an early stage. Further, we are also locating the optic cup to determine the cup to disc ratio for detecting the glaucoma. Finally, the severity of diabetic retinopathy is detected by the number of microaneurysms present in it. So this is a block diagram. In the pre-processing, we are making use of the principal component analysis technique and the image enhancement. And the next stage is the optic disc segmentation. In that, we are making use of the in-painting, stochastic watershed and region discrimination. And in the post-processing, we are making use of the circular approximation. This is our stages of work. So in the principal component analysis, the main purpose of this process is to reduce the dimensionality of the image. Then the image enhancement technique which we are making use of here is the adaptive histogram equalization. We are making use of this technique is because in order to improve the contrast in the image. Then we are making use of the in-painting algorithm which is used for the restoration of image and also for the removal and replacement of the selected objects such that the structure continuity is preserved. The next operation which we are performing is the morphological operators. Some of the common morphological operations which we are using here is the dilation and erosion. Their purpose is to expand the light or dark regions respectively according to the size and shape of the structuring element. Then finally the microaneurysm detection phase. Here we are making use of the extended minima transform. With this method we are finding out the stages of the diabetic retinopathy. Depending on the number of microaneurysms are present, the stages can be identified whether it is mild, moderate or severe. So this is the output which we have obtained. So the first image is the input image, that is the RGB fundus image. Then we are converting into a grayscale image. Then on performing the PCA, the dimensionality of the image is reduced and that is the output of the PCA. And for the enhancement, we are making use of the adaptive histogram equalization method to increase the contrast of the image. After performing the enhancement, then we are performing the in-painting method, in-painting technique. In this in-painting, the image is restored and some of the selected objects is filled with external information such that the continuity is preserved. So the unwanted parts of the image is selected and it is filled by some other external information. Then we are performing the morphological operation, that is the erosion and dilation, such that the relevant structure of an image is extracted. Then this is the final output of the watershed transformation. Then we are performing the thresholding operation. In this method, we are locating the optic disc separately. After locating the optic disc using the thresholding, then we are locating the center point in that optic disc. Then the iteration is performed. The iteration is nothing but it performs repetitive operation in order to locate the optic disc. Then this image, in this image, the centroid is again located on the RGB image. So this is the final output of the optic disc which has been located. Then thresholding operation is again performed to this optic disc located in order to determine the optic cup. Similarly, the same procedure is followed for this also. Again, the center point is located in that obtained optic disc, and this is the final output after locating the optic cup and disc. And also the measurement of the optic cup and disc is also detected such that the cup to disc ratio can be identified which helps in detecting the glaucoma disease. After locating the optic cup and discs, finally we are finding out the severity of the diabetic retinopathy disease. So for this we need the number of microaneurysms present in the fundus image. So we are detecting the microaneurysms with the help of extended minima transform. So with the help of the microaneurysms present in the fundus image, we are finding out the stage of the diabetic retinopathy. So this is the hardware and software requirements. Thank you.